Hi, class. Let's talk about functions in C++. What are functions? Well, they're just little pieces of code that we write that are apart from our main function. We've been coding in main for all this time, and now we'll see that, well, we can create other functions than main to perform specific tasks. You generally want to write your functions to serve one specific purpose. They shouldn't do, solve world hunger, but instead they should do one very specific task. And then, of course, they should be named very, very similarly to the task that they perform, so you can readily identify what this function does. Now, another great reason to use functions is for code reuse. I'm sure there have been many times when you have been coding and you've seen that, well, wait a minute, I'm tending to repeat these 3 lines of code kind of over and over. And that's where a function comes in beautifully. So rather than writing this repeating code over and over, let's just write it once. We'll write it here inside this function. And then whenever we want to write all of this stuff over here, well, we'll just call the function. Let's say the function's name is write. It's a bad function name, by the way, because write what, but let's just say write. And then rather than coding all of this and all of this and all of this, we will just call that function like that in our code, write, and we can call that as many times as we want. We could even put that in some kind of a loop. Where you have some tasks going and you might write again and then some more tasks down here. So code reuse is another powerful feature and great reason to use functions. And then finally, as you go on in your coding, you will get increasingly complex projects, including various files and modules and things. And functions help us to just think about modular design in our coding, a way for something to just fit in here and it can be used here, here, and here. Our code is very organized in blocks, and all of that's part of modular design. So now here's another way to take a look at functions. Okay, here's our function machine, and please forgive my horrible attempts at art. I was not an art major. I was a mathematics major undergrad. So this is just some magic machine. And we've seen these before in, movies, TV. We've seen them like in the famous I Love Lucy, Lucille Ball comedy. And this is really just nothing more than a conveyor belt. And we frequently will put items on the conveyor belt here that will serve as input to the machine. The machine then does things. They perform tasks. They, in our lingo, they will execute an algorithm. And then we get output things here that are processed. And whatever they are processed, well, then we can go and box them up and ship them on out. Well, this is exactly a function. So in computer science, and of course, we'll be coding this in C++, but the principles apply to practically every programming language that uses functions. We're going to have some code here with our function, and we can provide inputs to it. Inputs might be variables. Inputs might be some literals. Inputs might be other function calls, but primarily it's going to be variables. And then our function, well, when we go and tell it, okay, here's the input, go do your stuff, it will go and execute its algorithm and then it will output some type of result, and we then store that result. So the function is very easy to understand and get our minds around when we just view it as this conveyor belt. Now, there are a few variations of the conveyor belt. You know, sometimes there is no conveyor belt. We would just tell the function, okay, go do your tasks. You don't need any input from me. I don't need any output from you. Just go do the tasks. So when we turn it on, it does its algorithm, and then we're good. This might be like a function that would print a menu, or a function that would print a banner as part of our program start. Maybe it's a function that will display some random things. Most important to realize, though, is that this version doesn't need any inputs or outputs. So similarly, we could have a function that doesn't receive any inputs, but still gives us some output. And maybe that's where we tell it, okay, go and generate a 25 element array of strings that are of random characters. Well, the function then will do that, and it'll return to you, it'll output the whatever we're asking it to output. In this case, an array, which we'll get to in the next module, an array of strings. And then the fourth possible configuration is just where there's input, but there's no output. And by output, I mean nothing being returned from the function. I should talk about that real quick. When we have some output from the function, we're talking about what is being returned from the function. It's like the function is complete and it gives you this box. You open it up and this is what's being returned to you. And you know, the word output, don't misconstrue that as the output of the function. And don't misconstrue that as, well, the function's output. You can easily have count statements outputting whatever you want inside of a function. But when we say the function's return values or the function's, you know, assembly line output, that's when we're talking about the return values. Now, while we're on that subject of return values, we've got to remember that anytime we have a function that is returning some value to us, it is going to get lost, and that return value will be irretrievable unless we catch it. It's almost like it's coming off of this assembly line and we're sitting there and we've got to catch these products as they come, or else they'll fall to the floor and be destroyed. It's similar to that. Now we've got to catch it. And a lot of beginning computer scientists forget about this important step. But when you catch it, you gotta put out, you know, some kind of a bin and hopefully catch it. Now there's 3 ways to catch it. The first is to store it in a variable. And this is the most common thing that we'll program. We will receive whatever's being returned from that function, and then right away, let's just store it in a variable. That way we can use it later. You can also just count what is being returned. And although the return won't be stored in a variable for your use later, it'll at least be displayed to the console, and that, you know, provides some justification, you know, for displaying it. You know, maybe that's the report, or that's the final results, the final statistics. And then the third thing that you can do is to use it in an expression where that return value itself can then be part of some other expression, like a math expression. This return value plus this return value, and each one of those operands will be a function call that goes and calls some function and gets some number back. Okay, to review so far, we've learned that functions are perfect for code reuse. I'm going to demo that next, and you'll see, oh, that's kind of easy. Hopefully you'll get that vibe from all of this. They're perfect to establish modular programs and to write with modularity. They perform the exact set of tasks or the exact algorithm that you code. It's great for when you have large sections of code that are repeating and you need one reliable way of expressing that code rather than having the code go 10 times and maybe in the 8th one and the 7th one there's a typo. Well, this is going to give you repeatability and reliability for that code. And then finally, make sure that you catch your return values. Those are very important. And always remember the 3 ways to catch the return value. You can store it in a variable, you can count it, or you can use it in a math expression. So let's talk about code reuse. We've seen this before in our coding as well. When we're coding, say, a random number, and we've got the min and max all set as constants, so no issues there. But that is sure a lot of code to repeat every single time. When this code is not going to change, it's pretty much that's going to be it for the whole thing. Well, you could save a lot of keystrokes here by creating a function. And instead of typing out all of these keystrokes every single time, we're having to paste it, which just gets tedious. Maybe we create a function called, how about rando? We'll just understand that and we'll have in our documentation exactly what that does. And then wouldn't it be nice that that's all we need to do whenever we want to call some random number that's in this precise range? We could just call a function rando. And we could count it. And whatever this function's return value, which is going to be the random number itself, that return value gets substituted in for these characters right here, and we'll actually get output, say, 135. So that's the beauty of reusing our codes via functions, is that you can just use them whenever you want. It's almost like you're creating a little utility program, and you're saying to this, this utility program is so great, it's going to do a random number generation within a specific value and return it to you, and you can use that as many times as you want. Maybe we put it in a for loop. And we do something with a random number. Maybe we count it again there. Or the other thing that we can do is, let's say we've got that rando, we can assign it to a variable. So how about if instead in this for loop, let's call rando, and anytime you see this syntax right here, rando, and then the open close parentheses, that's a function call, and that's going to run the function. Just like we've always seen rand so far, rand is always going to run the function and return some large number that then is substituted into rand, and then the rest of this expression can use that number. Be the same thing. Anytime we use rando, it's going to substitute in an actual number. But this time, let's save it as a value. How about temp? We'll just save it as temp. And maybe we want to count it again. Maybe we want to sum it. We could certainly do that. Sum plus equals temp. And that's an example of then assigning it to a variable. And then the third option is, you can certainly, maybe you would have some expression like this. Randsum equals rando plus, say, a rando times 3. This is what I mean by using it in an expression. This is a math expression, and we can use that function call as one of the operands because we're guaranteed for it to return a number. Guaranteed. So that is showing the ways to do that. Now let's actually start looking at coding this exact little problem here and see kind of this code reuse in action. Okay, let's take a look at this code now. We see some very familiar things. One is that we've got our constant declarations up here in the global declaration area, and that's perfect. We see the main function that we're used to, but we are looking at a few other interesting things related to functions. Let me pop in a different color here. And so right here we see, come on, you. So right here we see what's called a function prototype. And then down here, we see a function definition. So in using functions, we'll have to remember we've got two things to code. They're related. There's some differences that we'll talk about, but you will have to write a function prototype, which is sort of an announcement that, hey, this function is defined somewhere. It's at the bottom of this code. So it's sort of an announcement, and without it, it won't compile because we've got to follow the rules for a function, which is a function's got to be defined before it is used. Kind of makes sense. So we will look at all four of these things in this video and figure out, just what to do with this stuff. Meanwhile, we've got that problem where we wanted to just write that rando function, and it's just then going to give us a random number without having to type that whole string over and over and over again. And this is exactly it. This is what we've got. So I've got my function prototype here. I'm calling it rando. And this function is going to return an integer. An integer is going to come out of that assembly line. So that's why we have an int right here. The return type of the data type of the return variable has to be listed right there. So if your return type is a string, then put string there, etc. When we get to arrays, we'll put arrays there. So that function prototype then basically needs to match then our definition down here. There'll be some departures from it, but for the most part, it's going to match. But notice right away, there's no semicolon down here. No semicolon at all. If you do put a semicolon there, the compiler thinks, well, all right, this function definition is now concluded, and it won't consider any subsequent code part of that definition. And then look inside the main function. You'll see that we have our function call right here. And since this function is returning a value, we've got to catch that return value. 3 ways that we can do it: count it, assign it to a variable, use it in an expression. So in this case, we're just counting it. And that will then produce that random number to the console. And here it's 943. Let's pop in sran times 0. And that'll start to vary that number away from 943, like 772 that we got here. We could repeat this code. And now that's going to give us 4 random numbers. We could use the return value in some kind of an expression. So this is going to pick 2 random numbers and multiply them together. Or we could put it in some kind of a loop. let's see, I think I'll store this in a variable so we can store it, so we can use it. So here I'm going to store that random number in a variable, and that way we would need to, we would want to store it so that we can use it in the next statement below. Note that if we did this, rando, these are different numbers. The line 15 function call to rando is going to generate its own number, and the line 16 function call to rando is going to return its own number. So if you want to sort of reuse that number, maybe outputting it or putting it in some kind of an expression or statement, well, then this is the path to follow here. Store it in a temporary variable, then you can simply use that temporary variable. And here I will output what the random numbers that were generated are, and then we can see what the sum of them is. And there we go. There's some results there. So this is showing a function that is repeating the same code over and over, and how you can then modularize it by just creating a function out of it. Now, here are some function-related terms to start using. You'll see this all the time in your coding journey. So we've got to start using the right terms right from the start. I showed in the code what a prototype is, and that is this slice of code up here. It is always before the main function, and it is sort of an announcement that later on in the code, you're going to see the full function definition for this function here called rando. So sort of an announcement, and this one is terminated by a semicolon, and then there's no other code in it. No algorithm, no task, no nothing. And then that's, of course, going to be related directly, related here to the definition. Because for the most part, most of these characters will just be repeated here. And of course, there's no semicolon here, or else the program will terminate early. That function will terminate early. Instead, we use a brace and we just create a code block that defines the algorithm for the rando function there. And then you'll note that our return values are actually sort of making sense now, aren't they? We've been seeing int main for our whole semester, and that's because the return value from the main function has always been 0. And 0 is just a generic code, meaning, okay, the program successfully ran. It's telling the processor, okay, we're done here, int main finished. And because that's a 0, that's why we've typed in int main all this time, because it matches the data type here. So similarly, since int random is returning an integer, then we will see an integer here, and that's so that these two match up. So that's the definition. And remember again that the prototype and the definition are almost the same thing, just one uses only the announcement or the function header, and the other one uses the complete definition. Now then, we've seen here that in our main function, we've actually called the function. So finally, that function call is when we've been calling the function in main. Right here is the function call. And a function can be called anywhere in the program, including by other functions. Sometimes, now this is way advanced, and if you keep on going into COMSC-165, you'll get more exposure to this, but sometimes a function can call itself. And that's called a recursive function. And those are fascinating to both code and to deconstruct and try and understand, but we won't get to those in this course. Okay, with these terms in mind, let's do a little bit more exploring with our functions. Okay, let's test our understanding with these two function definitions. One is int generate value, and the other is void generate value. So my question is, what is the difference between these two, and why does it matter? So think about that. What would be the difference of having int here, but void here? Okay, well, the answer is that one of them returns a value and the other doesn't. This one returns an integer, so we would expect to see a return statement in there with some integer value specified in there, either a literal or a variable. This second function here is void generate value, so it won't have a return statement and it is not returning anything. So that's what that means, no return. So that's our difference between those two very close, similar, but markedly different function definitions. Okay, our next major thing to discuss is providing inputs to these functions, inputs. Now, of the four types, two of the types of functions can receive some input. A void function that has some parameters, excuse me. And when I say input, I'm talking about parameters in computer science language. We will use parameters in our functions. So there's this one that we've seen before, and then there's this one that is also a parameter function. It's going to receive some values, but it does have a return value specified. So both of these will be called parameter functions. One is a void parameter, and the other is a value returning parameter. So we will wrestle now with how do we get these numbers into these functions? And it's simple. That's what the parentheses are for. The parentheses are going to contain a list of our parameters. So that is where we will inject data into this function machine or provide it some product to process. And sometimes we'll get something returned, sometimes we won't, because the function will just do its job. So let's look then at, well, this is great. How do we then actually do this? So let's track this with sort of a live example. And for that, you're going to have to catch the next video. This one is long enough. This current video is long enough, so I'm not going to torture you with a horribly lengthy video. So I'll split up how to send values as arguments in the next video.